And hello, everybody. We are live today with Szymon to talk about performance.
Hello there.
This is
Yes.
pretty exciting, Szymon. I didn't tell you that because I didn't want you to freak out, but this is the webinar that we have the biggest number of people signed up. It's usually few, and this one is over 200 people. So
Not bad.
it's it is still not as big as the live streams that we do on a regular basis, but still somewhat large. Um,
Yeah, and before we start, just a little disclaimer. I have a problem with my throat, so my vocal cords are not in the best shape right now. So please forgive me if you are not able to understand me correctly, but yesterday I couldn't speak at all. Today it's better. You can hear that it's better, basically. But forgive me if you cannot understand some of the words I would say during this webinar.
to be honest with you, you sound pretty good to me. Um, Maybe I just don't know what's your original.
More or less, yeah, exactly. Like I hear myself and I know that I'm not 100%
Yeah,
well in shape, let's say.
I have this funny story before we started. That in the building where I live, there was a security guard, and I've been passing by this guy for the past 6 months, and his voice is always, like this. And so I always thought that, it's just a guy, like that's just his original voice. And after 6 months, 2 days ago, I passed by and he says normal voice like this, hello. And I'm like, so he was basically sick. I just assumed that was his original voice. So I would say you're doing pretty good. That's the conclusion, I guess.
Yep. So without further ado, let's go to the most important part of this webinar. So the performance guide.
Exactly.
So
Yeah. So maybe we can start with a bit of a introduction to what is the ultimate guide and why are we even here today, or why you are here today. The ultimate guide to React Native optimization is this book that we release every year. I think the first edition started 6 years ago, maybe seven. It's basically something that we take for granted these days. And it is the go-to resource and collection of tips and tricks that we use at Callstack internally every day to fix performance issues for our clients. And so this year is very special because we decided to redo the guide entirely from the ground up. So rather than structuring the guide around things like CI/CD or maybe building native modules, we decided to structure the guide around JavaScript, React, and native, which is typically the three different things that you work with every day with React Native. And in the first, each part is structured around teaching you basics, so you have great understanding of what is it that you're building. Then you have some instructions how to measure things or how to check if performance is good or not, and some best practices. So each of the chapters is structured pretty much this way. And so today it's the first webinar from the series where we are going to talk about performance, why it matters, and we will tackle the very first part, which is JavaScript. We're building native apps, but at the end of the day, it's all JavaScript. And the reason that Szymon is today with me is, very special. He is the person that was leading the JavaScript part. He authored a lot of those pieces, and he is the best person to tell you everything you need to know about this part, answer any questions you have, show you some examples, and walk you through it page by page. So I guess before I pass it over to Szymon, all I can tell you is please ask questions as we go. We are more than happy to answer them on a rolling basis. The video is being recorded and it will be shared with everybody interested later as well. If you have any other questions, either leave a question in the chat or you can always email us at mike@callstack.com. Very simple email. We're always happy to help you figuring out some performance issues or whatever is the issue you have with React Native later. So this is the preface. I'm again very happy to see over 100 people here, and hello everybody on the chat. It's great to have you, and I guess without further ado, let's jump to the meat because we got a lot of interesting things to show you. So Szymon, all yours now.
Yeah, I just want to add that. Well, maybe I want just to explain why performance matters in modern mobile applications, and not only mobile applications, but generally in websites, in web applications, desktop applications, and also mobile applications. So as you probably know, uh, each second of delay may cause users to basically choose another app to buy something, choose another website, another eShop to buy some stuff. Let's say, for example, clothes. And there are many researchers saying that, for example, every 100 milliseconds of delay, or even less value than that, can cause you money in practice. Uh, there's a direct link between the delay between user initiating the launch of your app or your website, and the delay between launching the app or the website and ability to do anything in the app. So the startup time is also important because basically it costs you money. And that's why today I want to tell you more about how to optimize, how to look for performance problems in JavaScript side of the world. Because to be honest, this is the world where we have the most impact on. This is the world where we make, well, many mistakes. And today I want to basically show a couple of examples of such mistakes and provide you details how to fix that issues leading to bad performance, leading to not so great user experience. So my plan for today is to go through each section of the first part of the guidebook of the performance guide. And then for some parts of it, I have prepared something, let's say honeypot application with examples, practical examples of such issues. We will see how React DevTools, for example, allow you to basically, uh, debug those issues and how can you fix them with basically minimal code changes. So without further ado, let's start with the first part. So as you probably know, React allows us to debug its internals with React DevTools / React Native DevTools, depending on the platform we work on. So this tool is pretty special because you are able to see how your components are rendered during the lifetime of the application or during the profiling session to be precise. So for example, if I run the recording session right now, and bear with me because this setup is fairly complicated and that's the first time I'm doing that. So React Native DevTools, something you probably know. I'm in the profiler tab, basically having access to the React profiler. Moreover, I've enabled additional. I didn't do that yet, so I will do it right now. I want to know why given component renders, so I need to enable this option in the profiler options, and then we can start playing with the app. So let's start with the first section, and for example, let's start with context memoization, something simple. And the story itself is also simple. We use React context for many reasons. One of the reasons is to basically bypass several components in the component tree and just inject the context value wherever it's really needed. So we can basically mitigate the problem of prop drilling, of passing props through different levels of components just for the sake of passing it down. But the problem is that if we do it in a wrong way, this problem may lead into our code may lead into multiple renders of many components of our application without any reason to be rendered. So let me start the profiling session. And this scenario is pretty simple. We have a parent component with a force re-render button, which will basically update the state variable of this component. We have a theme component, which listens to changes in the theme context. And we have a toggle component, which enables me to switch the active theme from dark to white and from white to dark. So let me go to the code just to give you more details about the exact implementation. So this is the problematic implementation, let's say. As you can see, there's only one state. There's one function, basically changing the state from true to false and the other way. And we have this object named context value. And I want you to pay attention that this context value is not memorized. This context value is recreated every time the theme provider re-renders itself. It may be because some parent re-rendered, for example. And on each render, we will receive a different context value object. And this context value is used as a value for the provider. Now, the problem is that the React context looks for changes in value prop by reference. So even though the context value object is the same in terms of properties and their values, the reference to it is different. It means that every component relying on this theme provider will be re-rendered no matter if the context has really changed or not. So now let's go back to this setup and test it in practice. So let's start the profiling session, restart it, and force a re-render in this problematic scenario. When I stop it, you will see that, let me find the problematic screen. You can see that even though I used memoization for both components, for themed component, the component using the context, and the toggle component, again, using the context, but for different purpose, both are rendered. Why? Because the provider itself has rendered, the context value has changed. Therefore, React needs to render all consumers because there may be some change introduced that is valuable for those components. And the fix is simple. The fix is to basically wrap the context value in use memo hook. This time, the context value object will change only if one of the properties changes. Super small change, super easy to be applied, super easy to remember, and the result will be significant. Of course, this is just a simple scenario to show you what's the problem and how to mitigate that. But I did an audit, a performance audit of our application, like very large application used by hundreds or thousands of users across the world. And I found this problem 6 times in the code base. And by fixing that with this simple use memo hook, the difference was noticeable in practice while going through the app. So now I can go back to this screen, start a new profiling session, change from problematic to optimized variant, and force another re-render. But this time, if I find the correct, I think this is the one, correct re-render, you will see that themed component didn't re-render because there was no change to the context value. The same applies to toggle component. There was no change to the context value. So the only thing we did, we wrapped the context value in use memo hook. That's it. Performance will be better. Of course, the performance impact of this problem is limited to the position of the context provider itself. If it's near the top of your component tree, the performance, the problem may be not that serious. But if this provider is, for example, nested in some other component frequently rendering because of many reasons, then the impact will be significant and definitely noticeable. All right. So you now know that React context can be harmful for your performance, for the performance of your application. And well, basically we went through how can you use it in practice, how you can run the profiler, how you can, like, let's say, interpret the results. We'll of course get back to React DevTools in a minute, and we'll explore more features of this tool. But right now, I think you still have some valuable information about how to use it in practice. All right, so maybe instead of scrolling through the performance guide, I will simply go to a different scenario. So the second case I wanted to show you is the case of virtualized lists. Probably all of you heard about FlatList, FlashList, well, basically any component ending with a list suffix. So the problem there is that usually when we have a long list of items, the performance of scroll view is not really that good. Why? Because React needs to render hundreds of line items at the same time. You need to remember that with scroll view, everything you have in your React tree, React component tree, will be rendered at the same time. With FlashList or FlatList, the situation is different. There, you only render the subset of items, a subset visible in the current viewport of your mobile device. Of course, there's some, let's say, there's some buffer. So when you start scrolling down or up, you won't see those empty spaces. But you probably notice that if you go quick enough, you scroll quick enough, you will see those blank spaces because React needs to catch up and React needs to basically render additional components to fill this empty space. And there are multiple props for both FlashList by Shopify and FlatList. But I want to focus on one of them because, again, this is a problem I noticed many times, even in applications maintained by dozens of people. So it's not like it's only a rookie mistake. Not at all. It's sometimes visible even in professional code bases. So the flat list, nothing special. We have render item and we have key extractor. I want to focus on render item because you don't really, you can use flat list without key extractor. So we probably use render item only. And at this point, the thing is that I do not memorize the render item function. It's basically inline. And again, situation is the same as with context value. Every time problematic is renders, the render item is recreated, new reference is created. So FlatList notices that render item is different. And at this point, we have two options. Option A, in the eyes of FlatList, there are two options. Option A is to basically acknowledge that render item has changed and re-render all items because maybe the render item function changed significantly changed. Like we are supposed to render something completely different. Or we can do nothing because we may kind of assume that render item didn't really change in any significant way. So FlatList chooses the first option, and FlatList will render all visible items whenever render item changes and whenever the component rendering FlatList changes. So again, I have an example on the right side of your screen. Like I said, this is a simple list with, I think, hundreds of items. And when I switch the active view back to this one, and start the profiling session, you will see that when I force re-render, so only the parent rendering FlatList is rendered right now. You will notice that all the items are rendered again. And my DevTools are acting weirdly, but you should see that we have multiple cell renders being rendered because render item changed. Now, if I switch to the optimized version, and optimized version is basically wrapping the render item in use callback. Now, if I start again, you will see that the situation is different. Nothing really, Jesus Christ, nothing really renders because the identity is the same. This way, well, it may seem to be kind of the change may be seen as minimal, but at the same time, again, if your component, if your parent frequently renders because of reasons, your flat list will also render, and all the items visible on the screen will also render, which may have a devastating impact on the performance. Because, for example, user may be using some kind of a low-end Android device, which is not really great for such things to happen in the background. So that's the second thing I wanted to show you today. Now I want to maybe focus on something different, because probably all of you are aware that our actions in React can cause performance issues, frequent state changes, lack of memoization, like I showed you before. But now I want to focus on something different. So JavaScript is a single-threaded language. It means that if you, for example, execute some function, you cannot really execute a second function until the first one finishes. So in other words, there can be only one instruction executed at a given moment of time. And the problem is that if we spend too much time executing our work, our computations, for example, by, I don't know, maybe we can spend a lot of time on validating some user data. We may end up in a situation when the whole application starts to be unresponsive, or there's a slight delay between user event like touch and the reaction of the screen. And again, this is practical example taken from the audit I did last year. So in this case, in the application, there were dates, and dates needed to be formatted according to the local region of an user. Sometimes you format dates with month, date following. Sometimes, for example, in Europe, you format dates the other way, day, then month follows. So there's this API called date time format, which you obviously can use to do that. But the problem is that this particular object is meant to be created once and reused. But sometimes, like in this example from the last year, I noticed that this object was recreated over and over and over again for every call the format function. And I want to show you what's the result of such recreation, let's say. So again, we have two variants: problematic and optimized. We will start with problematic. I will restart the profiling session. I will click add date. Nothing important happens. You can probably see that a new item was created. But now, if we stop profiling and look at the problematic date list, you will clearly see that there's something wrong with that. The component itself, the problematic date list, takes around 20 milliseconds to render. And if you see something like this in your applications, it most likely means that there's something wrong happening in this component. There's some synchronous work executed during the render time of this component, and that's why you see it taking so long. If I now switch to the optimized variant, so the one which creates this datetime format once and reuses it, you will see that the difference is significant. So this time, instead of 23 milliseconds, you get only 5 milliseconds. It's still the amount of time spent for this component is still significant, but it's way better than 20 milliseconds, 4 times better at this point, with a simple change of moving datetime format from the render function to, for example, a global object. If we have only a single region in our application, then we can obviously use the global context. Do we have any questions at this point? Because to be honest, I have so many windows open at the same time that I cannot really see the.
There is one question, I think. I mean, there was a question about the app that you're using, which I already answered in the chat, that you created that for the purpose of the webinar. And if there is anybody who wants to have access, we are happy to chat about it with you later. However, there is one question that I can put up on the stream, and that is for the FlatList optimization. I believe it's somewhat related to what you just described about when we have state that we need to add a render item, and that changes a lot in the app, how we can optimize for that use case.
I mean, it's hard to reason about something like this without a code sample, without some kind of generic overview over the structure of your application, right? And let me think for a sec. Maybe I will.
In the meantime,
I will show the code for everyone to.
Yeah, because there is actually a question for FlatList and datetime optimization. Do we have that? In here.
No optimization, no use memo, and then we have the same render item, but this time with use callback. With use callback, basically the function wrapped with this hook is considered to be the same as long as nothing in the dependency array changes. So this particular example, the render item will be the same for the lifetime of the component. But coming back to the FlatList case, I think I have an example for that. For example, if you use Redux or any other data store, Zustand, or what was the pronunciation for that? It's German. Zustand. So
depends if we do it German or not.
Yeah. So if you use Zustand, usually you have a list of items, and then each item contains some properties you want to display. And the kind of normal way is to, when this item one of the items is being changed, to basically recreate the array to change its reference with spreading, and then create the object with spreading again with a new value. And now in this case, when we have a FlatList, all items will be rendered, the FlatList will be rendered. So the performance impact may be greater than if you just extract the list of items with, for example, IDs, because this list will be always the same as long as you don't add any new item at the end or beginning. And then in your render item, in the component you use in render item, you can basically select this single item you care about and observe it for changes. So in this configuration, instead of forcing the whole FlatList to re-render, you will just force a single component, a single item to re-render, which is better. And usually that's how you work with lists in Redux.
Szymon, I have some help from the chat on how to pronounce it.
This is fun in German. Like everything is so hard. let's say, like sounding hard. Justant.
Yeah. Okay. So before we move on to another example, I guess one more question is, and I think we talked about it as well at the beginning, regarding the memoization. And like from your experience, the question is actually two questions. I'm trying to read them and ask them at the same time, which doesn't help. So I'll just show them. Does React memo helps with the performance when using FlatList? And then, um, and then I guess another one which is related is if we use a component name for render item rather than an inline function, do we have the same performance issue as an inline render function? If so, is optimizing as simple as using React memo, for example, render item, my row component?
The problem there. Okay, so let's start with the latter.
Wouldn't it hard to type it down there quickly without even re-rendering? Just visualize what is the sort of, because my problem on a live stream is that when I read the questions, I never understand what they mean. So, at least from that perspective, let's see if, actually, there you go. Looks like the Copilot knows exactly what are we even talking about.
Like this. So the problem will be definitely with types. Because this render item, if we go into it, and we can, it expects React element to be returned. So technically it should work. The prop itself, because if you look at the signature, it looks like React component, right?
But so why would you memorize? Why would you memorize the component itself in that case? If that's
the outcome will be probably the same or pretty much similar.
Yeah.
The only difference is that and I think that's also true, and sometimes it's I think it's even mentioned in the docs of React itself, of React Native itself, that this render item may be executed multiple times, like very frequently. So if you have anything complex inside, it's better to memorize it, only the internals of this function. So I would say memorize item, like this, for example. So even if FlatList decides to execute this function multiple times, you will still reuse the previous component because this is memorized component, and the item may not even change, right?
Yeah. Szymon, I have a question actually, because it always intrigued me as well. We talk about it quite a lot, and my observation with some of these performance optimization techniques and do's and don'ts is that we often tend to just stick to some common truths without even doing the measurements ourselves. And one of the things that I often hear, which is actually a very good question from the chat as well, is the memory consumption of memoization, right? And it's obviously something that we talk a lot about. And there is another question in the chat as well. Like we generally talk a lot about that. And I think in most cases, when you build relatively small application, I cannot think of a scenario where you will run out of memory or have memory consumption spike, unless it's a large application with maybe a lot of state. So I guess given your background on some of the larger applications, maybe you have something to add in this. What are the scenarios from your experience where we could run into something like that? I think it boils down to measurements, but I think some of the optimizations in that regard, at least the way I've seen them in many companies, were, I would say, done in advance without actually I don't think I've seen anybody running into memory issues with use memo just because they started with this assumption from the very first place that they need to be careful about using them to start.
Yeah, memory is cheap. So with a lot of memory to be, put into use. And to be honest, unused memory is wasted memory, basically, because it's here for us to use. Unless we obviously go too far with that and end up in a situation when, for example, app is killed because we are using so much memory that system says it's enough. I need memory for something else. But it boils down to kind of, I would say, some heuristics you learn during your professional journey. You see certain patterns that necessary need memorization. For example, I have one great example. If you create any custom hook, and if you have to expose any function from it, so use my hook, and let's say I would do something like this. Now, the problem is that with such setup, the consumer of this hook needs to be aware that my render item is not memorized and is going to be changed frequently. And I've seen many cases when people were not aware of that. And for example, we're using this render item in, for example, use effect, which can cause, many issues because certain effects will be called multiple times when in reality they should be called only once. So for example, my personal approach is to, if I create a custom hook and I don't want to kind of force my consumer, the hook consumer, to remember that if he wants to use this particular function, for example, in use effect, I don't want the consumer to basically memorize it themselves. So what I do is I always memorize my functions returned from custom hooks, just in case, because this time it boils down to developer experience and to trading some of memory consumption for, let's say, for the safety of the code we write. But generally, FlatList memorization is a way to go. Like this is the one of the places where I wouldn't really think a second time about applying memorization. When it comes to simple UI building without any special, let's say, requirements, then I would probably never apply memorization by hand. I would create everything from scratch with inline objects, for example, and profile afterwards to see if memorization is really needed. On the other hand, with the brink of React compiler, which will basically do memorization of everything, I wouldn't say that memorization is something that we have to necessarily pay a price for. Like the compiler will do the same thing and will do even more memorization that we as developers do in day-to-day work. Because compiler can, for example, memorize parts of the React component tree, which is not something common. You can obviously do that, but it's not common in code bases to memorize parts of your component tree just to gain some performance.
And I think adding to this, I think measuring memory impact of use memo might be extremely tricky, but it's much easier, obviously, to measure immediate performance benefit of rendering speed, for example, once we apply it. Now, one example that always stays in my mind is when I worked on a crypto wallet application. And they had this crazy approach of applying use memo everywhere from top to bottom. Like literally it was everywhere, callbacks and memos like just by default. And obviously when you use it that much, I mean, still nobody ever measured memory. It was not an issue. I mean, obviously you're running on a Mac, you're optimizing for the high-end devices. So it is very unlikely you run out of memory on a web application. But still, and that will lead to problems obviously, because, when you're dealing with crypto and Web3, there's like a bunch of other things that keep your memory busy. Anyway, my impression was that the application was actually slower because of all those memoizations down the tree for things that don't necessarily make a lot of sense. So I wasn't really sure about that. So I would say, kind of, I do agree with you. And what I always sort of keep in mind is that with React, the declarative model, you're sort of offloading the rendering logic to somebody else. In that case, the React Native renderer, or if you're doing the web, React DOM. So by default, I always assume that it should work fast and good enough without any of these. And then when we use things like Reassure, or maybe we measure with the DevTools, we can see some issues. That is when we can selectively apply the optimization, but be smart about it. Rather than, I'm just going to do the callback and memo here because I'm feeling it will be needed. Obviously, it may help, but in most cases, it might be as well just unnecessary because the device is just fast enough. So that makes sense to me.
Yeah, I mean, if the app works quick enough in all the devices users use, because we can have some kind of insights on what devices our clients use. Then it's not a problem at all to not have memoization in place. The app is quick enough for the use case. But sometimes if you run the DevTools, React DevTools, and you see that components run like 100 times in place of 4 times, well, that's the threshold you may assume to be, let's say, if you can limit the number of renders by 10 times, for example, then it's useful to basically apply memoization, because the impact should be noticeable at this point. Of course, if you have 5 versus 1, the impact isn't really that huge, if even noticeable. But if you have 1 to 100, that's a totally different story.
Yeah, that makes sense. So, Szymon, I think we can start moving on to the next chapter a bit. This was a pretty good discussion. We still do have some questions around FlatList in the chat, but I also wanted to go over the other things we have. So I would say to everybody who left a question that remains unanswered, or we did answer anyway, we will get in touch anyway. So don't be worried. So just please keep shooting questions in the chat. If we can answer some of these as we go, that's fine. Otherwise, we'll try to help anyway. But I already see that we will not be able to cover everything, so we will have to do a follow-up.
15 minutes left. There's 6 sections.
I would lie that we kind of did expect that to happen anyway, which is to a certain extent good. Cool. Yeah, let's move on, I guess. And then I see we have to follow up on the FlatList later as well.
Just a short comeback to the data and format. The faulty function recreates the formatter every time it's called for every date. It will be a little bit better if you put, for example, data and format here. So it'll be created once per, no matter how many dates. This structure is basically put here to cause extreme difference to be noticeable in DevTools. The correct usage is to, if you need, for example, to create this format with some local data, you can obviously use memo. You can put it in global context if you like, and you can reuse this data format for all formatting in your application. So that's this part. And now let me go quickly to my emulator. So I guess we'll skip those. And for example, which parts should we now focus on? All right.
The next one, or I mean, okay, go with the fancy ones. If we're in the animation,
yeah, I mean, maybe not the fancy ones, but something that also is really also happens really common. It's a really common problem in applications. So I want to talk about doing some heavy work in our applications. For example, some I think 10 minutes ago, I mentioned the problem of validation. Like if you have some super big form to be validated and validation rules are so complex that they can take some time to be executed, you may end up in a situation when user, for example, tries to click some button and there's no response from the system because the app is still validating stuff in the background. And again, practical example of that is, um, well, for example, I worked on an application where I had a workflow editor, and in this workflow editor, users were able to basically create nodes, connect them together to create this big ass workflow. And each of the nodes included, I don't know, 10 or 20 properties. And the worst part is that sometimes those properties were uh, related to other nodes. So if anything changed, I had to revalidate the whole workflow because changing a single node may have caused issues with some other node. And obviously, it worked okay on my development machine. Everything was perfect. But after some time, we started to receive basically bug reports that somebody is trying to use our application, is trying to write something in an input, and basically between each keystroke, there is, I don't know, half of a second of delay. And after investigation, it turned out that the validation itself was a synchronous work. So, like I said, there's only one thread, only one operation at the time can be executed. And this validation took around a second on some, let's say, medium end devices. So not that low end devices, not the cheapest one, but also not the most expensive one. And yeah, example. So we have the screen, two buttons. One button basically executes this synchronous work. So in our example, it's basically uh, this is our heavy work. So we do a computation, we iterate 1 million times, 10 million times. We iterate 10 million times and then we get the result and that's it. This is a simulation of some complex work to be done in the background. So now if I run the heavy computation and I try to increment, you should notice that there's this delay. Like nothing happens for a second and then the counter updates 4 times, for example. Like now it went from 13 to 18. That's because JavaScript thread is working on my computation. Obviously, the UI thread is handling events coming from user, but JavaScript is still working on my computation and cannot really handle those events. So those events are piling up on the UI thread, waiting to be handled by the JavaScript thread. And that's the problem. Sometimes we don't have opportunity. We don't really can move our computation, for example, from the application to some kind of service like API service. So what we can do in such case? So I have this second example doing pretty much the same, but this time with yielding. If I run this one, you can see that the same thing is happening, but right now I can I can increment the value and the value is visible to be updated. And every time I click without noticeable delay. Yeah, and how is that? This is the code without something called yielding. By yielding, we name the operation of giving back control to JavaScript, like yielding is basically stopping work right now, giving time for JavaScript engine to work on something else, and then coming back to our work to continue it. So basically what we do, we split our big task into smaller tasks, into set of, for example, 100 smaller tasks. And the idea here is that the first task is executed. It takes, let's say, 50 milliseconds. Then JavaScript engine is looking for new work to work on, basically. If there is any event coming from the UI thread, so for example, any user event, not browser, because it's not browser, but JavaScript engine will choose to handle this user event instead of our second task. So this way, you can see that when I increment, JavaScript thread takes my user event, it handles it, so the counter is updated, and then it goes back to my second task, executed it, and then again, this process continues as long as there are any tasks left. So as long as we do yield, we give control back to JavaScript engine, our application will be still responding to user events, which is great. But the problem there is that you can't really apply this pattern to pretty much everything. Your type of work needs to be dividable into smaller tasks. So, for example, validation is such type of task. In my case, I basically split my workflow consisting of hundreds of nodes into smaller chunks of, I don't remember exactly, maybe it was even chunk of a single node. So I went node by node, validating, and then giving back control to the browser because it was a web application. And the problem was gone. Basically, users were able to use the application no matter if they had Chromebook for $100 or if they had, I don't know, MacBook for $7. I know what's price in dollars for MacBook, but let's say $2,000.
That's what it costs to buy the one with the touch bar because it has broken keyboard. That's the one nobody wants.
Yeah. So this is the part of about yielding, and I see many messages in comment section, but I guess there's no additional question, right? Can I use promise instead of yielding? Can you, Mike? Yeah, like that. So this is interesting story because if I want to describe the whole, let's say, event loop and all internals of how tasks are handled by JavaScript, I would need another hour to do so. But if you wrap your work, your synchronous work, your, for example, validation in a promise with, for example, let me change the code. So you probably mean something like this: promise, new promise, result, maybe computation, return result. Okay. So results, this is not really needed. And let's say we will use then result and apply it here. So this time our synchronous work is wrapped in like this. This time our synchronous work is wrapped in a promise. So the common understanding of promises is that somehow, magically, promises are executed in the background. Because, for example, if we do a network request, it's a promise, it's executed in the background, and JavaScript is basically notified that there is some response waiting for handling. But this case doesn't really change a thing. Like if we go back and I will quick enough, you will see the same thing happens. Because with promises, with new promise and then resolving it inside of it, you basically end up with a task. Again, this is again a task. The executor, so the function you pass into the promise constructor, will be executed, I think, as soon as possible. So it can be even blocking in the same way like synchronous code. And this part in them will be scheduled as another task. So in the end, you will end up with the same output, because the task itself, no matter if it comes from our synchronous code or it comes from any asynchronous code, it's still a task. And task, if it's started by JavaScript engine, needs to be finished, fully finished, before the engine is able to go to the next task. So in this case, promises won't help you. I think 2 more minutes, and we can.
Sounds like good time for a break, because otherwise we open another box of questions with another topic, right?
Yeah. So I have another section about start transition, about concurrent React. We are not going to go into it today. I guess we will have a second meeting to go through all other sections we missed
We'll
today.
see how many, because judging by the number of discussions, I feel like we should have done one per each subchapter. Maybe make it shorter. Okay? Great. I think the conclusion is that, I mean, I'm at least super happy that we had such an interactive discussion, because I don't really remember the webinar where we had as many engagement with the audience. So I wanted to say, I mean, Szymon, first of all, like, kudos to you for running this live and doing those questions live. I think this was amazing. And everybody on the chat, you were awesome with questions and being here and following along. So that was really amazing to see and write down all the notes. I'm happy to follow up with some of you as well. I think we will have another session as a follow up, or maybe even a few more. And in this case, we will share with you an email. So expect an email at some point this week with an invite to another one, so you don't miss it. We typically do webinars every 2 weeks. So that's where the next one may come in. And if you have any other questions, please let us know. Szymon, before we finish, if you could open up this little survey, I will send it to you on Slack in the link. We have created a small survey with the link. We left in the chat already, but I'll just maybe we can also just show it here. It is a survey we did in Google surveys, so you can help us by letting us know what are the performance challenges you have. I'm once again going to paste it right here. Please fill it out if you would like to leave some questions to us, so we can cover them on the next webinar, and we can also make sure that the next guide has even better coverage. We would like to make sure that our guide really answers all the challenges that you're dealing with. Right now, the guide mostly covers the challenges that we see, but judging by the questions you all had today, there is clearly a lot of others that we'd like to cover for you. So please just spend some time and fill it out. We will be more than happy, and we will let you know about next one. And with Szymon, then we will have to go over the rest. He has prepared a lot, and I'm sure by the time we meet, there will be even a few more.
Yeah. And when it comes to the code of this Chronicle application, well, I guess I need to tidy it up a little bit, because it will be no surprise probably for you that this application was, let's say, generated in 80%. So I knew what I want to present, but I was too lazy to basically do it myself. So I used Cursor to generate it. And I would like to double check that there's like nothing, well, weird inside, just to be sure. Never trust AI, never trust LLMs, never trust ChatGPT or whatever model you use. So I guess we will basically send a follow-up email and just include the GitHub repository link inside. So we will be able to.
that will be the case. So I guess with that in mind, we are 9 seconds from a full hour, which is perfect timing to say thanks again. And we will be in touch with the next one and with any questions that left remained unanswered. So thank you, Szymon, and thanks everybody. It's been an amazing hour, and see you next time.
See ya.